Hello students, today we are going to cover a topic AC and DC current. So let us start with the topic. As we have already seen, current are of two types. One is direct current and the other one is alternating current. Now let us go ahead and understand in detail what direct and alternating current means. So for direct current, if I can draw the signal, the horizontal axis, x-axis represents time and the vertical axis represents the magnitude, y-axis represents the magnitude of current which is flowing. So we can represent the current which is having a constant value. Let us say this value is I, with reference to this value 0 over here, and it is going to remain the same throughout till the source is connected. On the other hand, if we go on to draw a signal which is an AC signal, once again horizontal axis is time axis and the vertical axis is representing current. So this is how the AC current looks like. What we can see over here is the value of the current increases from 0 and goes to some positive value, increases and goes to some positive value, let us say 3 in this case, and again it comes down to 0, and from 0 it goes down to have negative values, and let us say over here also it comes down to minus 3 volt, and again it increases and goes to 0, and the same thing repeats once again. So what we can say over here is, for some time the values of current is positive and for the other half the value of the current is negative. Again same thing repeats, again values of current is positive and negative. So we are seeing this as an oscillatory nature of AC current, where it keeps on switching from having positive values and negative values. It is not like that DC source ka value does not change. A real time diagram for this might look like this also. If we are turning on the supply, DC supply, let us say a battery or switch which is connected now, then in this case the value of the current will increase from 0 to some finite value, and then it will remain constant till the time the device is on, and when you turn off the device this value will again fall to 0. So there is this change in value in the DC current also, but it does not goes from positive half to negative half and again positive half and again negative half. The change is only observed whenever the circuit is turned on or off. Otherwise, output of the DC supply or the DC current ka value remains same. So I hope you all understood the basic difference between AC and DC. Now let us try and understand with respect to the circuit diagram. So if we have a DC source having potential V and it is connected to a resistor, then the current I flows from higher potential to lower potential in this case. But when we connect this same resistor with an AC source, then in this case, when the current ka value is positive, the current will flow in this direction, let us say, and when the current ka value is negative, yani it has gone into the second half, in this case current flows in the opposite direction. So this way current in AC circuit flows in both the direction, but over here in DC circuit current flows in single direction. Now when we have to transmit electrical signal for a larger distance, what we do is we use AC current for transmission. So for long distance transmission we use AC current because it is efficient and the power loss is minimum, and that is why even the electricity supply that we have at our homes, offices, colleges, everywhere, it is an AC supply. Now one more very important thing is, this positive half and negative half constitute a cycle of AC signal, and the signal that we receive at our home, it is of 50 hertz. It is having frequency 50 hertz, which means it completes 50 cycles per second. I hope you all got the clear understanding of the topic now.